So we are talking about prism. We have seen the prism formula. Now suppose this is a prism. This is a prism. If you make a light ray incident on a refracting surface AB, this is incident ray and angle of incidence is I. Now you know this is air, this is a transparent medium whose refractive index is greater than air. So light when will go from air to denser medium, it will bend towards normal. So it will not follow this path, it will bend towards normal. Let it goes like this. This is angle of refraction at first surface. So let it be R1. Now this ray is incident on face AC. If I draw normal on face AC, it is normal on face AC. Let this angle be R2. So this R2 here behave like angle of incidence, and at light goes from denser to rarer medium, so it will go away from normal. So this will go like this. Now if I increase this angle of incidence R2, this angle of emergence will also increase, because sine of this angle, ratio of sine of this angle and sine of this angle is a constant. So if the value of this angle increases, this angle also increases. And we know that R1 plus R2 is prism angle, that is a constant. So if R2 increases, then R1 should decrease, only then sum of these two will be constant. So if I increase angle of incidence R2, R1 will decrease. Now suppose I start increasing this angle of incidence R2, so angle of emergence start increasing. At one time, suppose this R2 maximum becomes equal to C, then what will happen? This angle of emergence will be 90 degree. So light will go like this. Grazing emergence, what you called. So when this angle of incidence, that is R2, becomes equal to C, angle of emergence becomes 90 degree. Now if this R2 is greater than C, then there will be total internal reflection here. So if R2 is greater than C, then there is total internal reflection here, and light will not come out of prism from face AC. So if you want that light should not come out from prism from face AC, then R2 minimum should be greater than C. If R2 minimum is greater than C, it means minimum angle of incidence here will be greater than C, so there will be total internal reflection here. It means if R2 minimum is greater than C, then there will be total internal reflection here, right? Now if R2 is minimum, then R1 must be maximum. So R1 maximum plus R2 minimum should be equal to A. So from here, what is value of R1 maximum? This is A minus R2 minimum. This is R1 maximum. Now here too, if you increase I, R1 will increase, and I can increase I maximum up to 90 degree. Beyond 90 degree I cannot increase I. So what is maximum possible value of R1? R1 will be maximum when I will be maximum, and maximum value of I is 90 degree. So if I is 90 degree, then R1 will be maximum. So here if I is maximum, that is 90 degree, R1 will be maximum. So if I use here Snell's law, what I can write? 1 into sine maximize 90 degree is equal to mu into sine R1 maximum. So sine R1 maximum is 1 upon mu. I can write it like this. And we have already seen that sine of critical angle is 1 upon mu. This we know. So from these two equations, at place of R1 max we can write C, because this side is equal and this side should be equal. So from here we can write R1 maximum equal to C, critical angle. It means if R1 maximum equal to this, then I will be 90 degree and I cannot increase I further. So maximum possible value of angle of refraction R1 is C. You cannot increase R1 more than this. Now if I put R1 here, it is C, R1 max. So C is equal to A minus R2 minimum. We can write it like this. So what is R2 minimum from here? R2 minimum is A minus C. We can write here R2 minimum is equal to A minus C. And R2 minimum should be greater than C. Only then light will not come out from face AC for any angle of incidence. So if I put A minus C at place of R2 minimum, and that is greater than C. Now add both sides C. So A minus C plus C greater than C plus C. This is cancelled. So A greater than 2C. So if this condition is satisfied, if A is greater than 2C, then light will not come out from face AC of prism irrespective of angle of incidence. You can have any angle of incidence, but you're not going to get light coming out from here, from face AC. It may come from base, but it will not come out from face AC. So this is condition of no emergence of light from prism from face AC or from refracting surfaces. This is first refracting surface, this is second refracting surface. So no condition of no emergence. This is condition of no emergence. Condition of no emergence. Condition of no emergence means for any value of angle of incidence, you're not going to get light coming out of prism from face AC. It means for any value of angle of incidence light will not come out of prism from face AC. And what is that condition? The condition is A should be more than 2C. If A is more than 2C, light will not come out of prism from face AC. If you take sign on both sides, so it is sin A should be more than, or you can write it like this, divided by 2. So sin A by 2 should be more than sin C. And you know that sin C means 1 upon mu. So mu should be more than 1 upon sin A by 2, or mu should be more than cosec A by 2. So these are the two conditions you should remember. If this condition is satisfied, that for any angle of incidence, light will not come out of prism from second refracting surface. From face AC means from second refracting surface. Second refracting surface. Second refracting surface. So these two conditions must be satisfied. Condition number 1, condition number 2. So condition for no emergence. So remember, this theoretical question may be asked on this. Now, condition for grazing emergence. What does it mean? Suppose this is a prism. This is a prism. BC, prism ABC. Now if light is incident like this, and emergent ray passes like this, means angle of emergence is 90 degree. Then this is called grazing emergence. It means angle R2 should be equal to critical angle, because when angle in denser medium is critical angle, angle in rarer medium is 90 degree. So this angle is critical angle, and let this angle be R1. So when R2 is equal to critical angle, angle of emergence will be 90 degree, and in this condition we say that emergent ray is grazing or grazing emergence. So what should be value of angle of incidence for grazing emergence? Now in this case we know that R1 plus R2 is equal to A, and in this case R2 is C, so R1 will be equal to A minus C. This will be equal to R1. Now if I apply Snell's law here, refractive index of this prism material is mu and this is air. So if I apply Snell's law, refractive index of air into sin I should be equal to refractive index of prism material into sin R1. So it is sin I is equal to mu sin A minus C at place of R1, and we know sin A minus B is sin A cos B minus cos A sin B. So use this identity, sin A cos C minus cos A sin C. I can write it like this, and we know that sine of critical angle is 1 upon mu, refractive index of rare medium upon refractive index of denser medium. So cos of C is 1 minus sine square C. So it is 1 minus 1 upon mu square, or mu square minus 1 root divided by mu. This is cos C. So if I use this, what I can write? Sin I is equal to mu into sin A cos C, that is under root mu square minus 1 upon mu minus cos A, sin C is 1 upon mu. Now take 1 upon mu common, so mu, and I am taking 1 upon mu common, so it is sin A under root mu square minus 1 minus cos A. This is concept. So sin I is equal to this, or I should be equal to sin inverse mu square minus 1 का root into sin A minus cos A. If angle of incidence up to this or lesser than this, then there will be no emergence at second surface, because if I lesser than this, R1 will be lesser than this, R2 will be greater than this. So if angle of incidence is this, angle of emergence will be 90 degree. If angle of incidence is lesser than this, then there will be total internal reflection at face AC, and if angle of incidence is more than this, then there will be a refraction at face AC. So remember this, if angle of incidence is lesser than this, there will be TIR at face AC. If angle of incidence I0 lesser than I, then there is TIR at second refracting surface, at second refracting surface. Can you tell me why? Because if angle of incidence you decrease, R1 will decrease, so R2 will increase, means R2 will be more than C, and if R2 is more than C, there will be total internal reflection. If angle of incidence is greater than this, then there is a refraction at second refracting surface, and if angle of incidence is equal to I, then grazing emergence. When angle of emergence is 90 degree, then angle of deviation produced by prism is maximum. So in this case, angle of deviation produced by prism is maximum. So we can also find maximum angle of deviation. Maximum angle of deviation. Maximum angle of deviation. You know, angle of deviation is I plus E minus A. So when E is maximum, angle of deviation is maximum, means when E is 90 degree, angle of deviation is maximum. When I is 90 degree, angle of deviation is maximum. So for angle of deviation to be maximum, either I should be 90 degree or E should be 90 degree. If E will be 90 degree, then I can be calculated from this formula. And if I is 90 degree, then E can be calculated from this formula. So this formula is valid for both I and E. If I is 90 degree, E will be this, and if E is 90 degree, I is this. So delta is maximum when either I or E is 90 degree. So maximum deviation is I plus 90 minus A. So this is maximum deviation, and I, we can write this. So this is maximum deviation produced by prism. This is NEET 16 question, and question is that prism angle is 60 degree and angle of incidence is 45 degree. Prism is kept in minimum deviation position. So find minimum deviation and refractive index of prism. These two things we have to find. So if prism is in a state of or condition of minimum deviation, then I is equal to E, R is equal to A by 2. This we know. So minimum deviation is I plus, at place of E we have to write I minus A. So it is 45 plus 45, 90 minus 60 degree. So it is 30 degree. So minimum deviation is 30 degree. Now if you use Snell's law here, 1 into sine 45 degree is equal to mu into sine R, that is 30 degree. Because R is A by 2 and A is 60 degree. So sine 45, that is 1 by root 2 is equal to mu 1 by 2. So mu is 2 upon root 2. We can write 2 as root 2 into root 2 divided by root 2. This is cancelled. So mu is equal to root 2. So this is your answer. Now this is another question asked in 2015, and this was a good question. There is 3 colors of light: blue, green and red, incident normally on this face of isosceles right angle triangle prism. This angle is 45 degree. So you have to tell which color out of 3 will be separated from other 2. Refractive indices are given here. For blue color it is 1.47, for green color it is 1.44, for red color it is 1.39. Refractive index inversely proportional to wavelength. So lesser is the wavelength, more will be refractive indices. Now here you see, if it is a prism, right angle isosceles prism, suppose this light goes and incident here. So here angle of incidence is 0, so angle of refraction will be 0. Now if you do normal here, this angle is 45 degree. So this angle will also be 45 degree, corresponding angle. These two lines are parallel and this is transversal, and this hole is 90 degrees, so this will be 45 degree. So here angle of incidence is 45 degree. Now we know that sine C is 1 upon mu, and if mu is root 2, that is 1.414, then this will be 45 degree. If mu is more than this, then the hole will be lesser. It means C will be lesser than 45 degree. If refractive index here is less than root 2, then this will be more, C will be more. So if you compare here, for red color refractive index is lesser than √2. So if it is lesser than √2, it will be it means it will be more. So this will be more. So critical angle for red color is more, but critical angle for blue and green will be lesser than 45 degree, because if refractive index is √2, critical angle will be 45 degree. If it is less than √2, critical angle will be more than 45 degree. If it is refractive index is more than √2, critical angle will be lesser than 45 degree. So from here we know, if refractive index is more than √2, then critical angle will be lesser than 45 degree, right? Because if it is √2, then critical angle is 45. If it is more than √2, then critical angle, if this increases, critical angle decreases. So if it is more than √2, critical angle will be lesser than 45 degree. If it is less than √2, then critical angle will be more than 45 degree. So here mu, if mu is greater than √2, critical angle is lesser than 45 degree. If mu is lesser than √2, critical angle will be more than 45 degree. And if mu is √2, critical angle will be equal to 45 degree. Now if critical angle is more than angle of incidence, suppose light is going from denser to rarer medium, and suppose this is critical angle, this whole is critical angle. So if angle of incidence is lesser than critical angle, angle of incidence is lesser than critical angle, then refraction will occur. If angle of incidence is more than critical angle, then total internal reflection will occur. So here angle of incidence will be 45 degree for this, for this, for this. Angle of incidence will be 45 degree for all three color. And we know that for red color mu is less than √2. So critical angle is more than 45 degree. Critical angle is more than 45 degree. It means red color will be refracted. And for all other color, there will be total internal reflection. So blue and green color will come together and red color will go in this side. So that is your answer. Equilateral prism. Equilateral prism, angle of prism is 60 degree. Refractive index of prism material is 1.6, that is given. And this prism is kept in water. This prism is kept in water. Refractive index of water is 4/3, and it is kept in minimum deviation position. It is kept in minimum deviation position, means refracted ray is parallel to base, so deviation produced is minimum. What is that minimum deviation is, that we have to find. So you know prism formula. Prism formula is refractive index of prism material upon refractive index of surrounding is equal to sine angle of minimum deviation plus a/2 upon sine a/2. That's you know. That is given, that you know. One more thing is given. Sine 37 degree is 0.6, that is also given. So use this formula. It is 1.6 divided by 4/3 is equal to sine minimum deviation we don't know, so minimum deviation by 2 plus a by 2, a is 60, so 60 by 2, 30 degree, divided by sine a by 2, sine 30 degree. So 3 into 1.6 upon 4 is equal to sine minimum deviation by 2 plus 30 degree divided by 1 by 2. So 2 will go up, right? If I cancel it, it is 0.4. If I cancel this, it is 0.2 into 3, so 0.6. 0.6 equal to sine minimum deviation by 2 plus 30 degree. This is sine 37. Sine minimum by 2 plus 30 degree. It means this angle should be equal to this angle, so we can equate a minimum by 2 plus 30 degree is equal to 37 degree. Minimum by 2 is equal to 7 degree. So minimum deviation is 14 degree. So this is your answer. This is asked in JIPMER in 2015. Now another question on Prism. It is also asked in 2015 AIPMT. The question was like this. This is a prism whose prism angle is A. This surface is silvered, and when light is incident at angle of incidence I equal to twice of angle of prism, light is refracted and incident on second face and reflected back. So if it is said that incident ray is reflected back at angle of incidence is 0 degree, then here R2 is 0 degree, because when ray incident normally, then only it retraces its path on mirror. So here R2 is 0 degree. So R1 will be equal to A. And we have to find refractive index of this prism material. Find refractive index of prism material, that was question. So apply Snell's law here. 1 into sine 2A is equal to mu into sine R. Right? And R is equal to, R means R1 and R1 is equal to A here. So sine 2A is equal to mu into sine A. So sine 2 theta is 2 sine A cos A is mu sine A. Sine A cancelled. So mu is 2 cos A. So this is your answer. Now there is another question of AIPMT. The question was, this is a prism, refractive index is 3 by 2, that is given, and it is kept in minimum deviation position such that angle of minimum deviation is equal to angle of prism, that is given. Then find value of angle of prism. Find value of angle of prism, that is asked. So you know this prism is kept in air, so mu of prism upon 1 is sine angle of minimum deviation plus A by 2 upon sine a by 2, that is Prism formula. So here 3 by 2 is equal to sine a plus a by 2 upon sine a by 2. This we can write sine 2 times a by 2. So 3 by 2 is equal to 2 sine a by 2 cos a by 2. I am using identity sine 2 theta divided by sine a by 2. So sine a by 2 cancel. So it is 3 by 2 is equal to 2 cos a by 2, or 3 by 4, I am moving this 2 on this side, is cos a by 2. Now a by 2 is cos inverse 3 by 4. So a is 2 times cos inverse 3 by 4. This is the answer. So these are the few questions regarding Prism.